Good day. Now we are going to discuss about chi-square. Chi-square is a measure of the differences between observed and expected frequencies of the outcomes of a set of variables. And we are going to tackle right now about only one sample, only one variable. Also, chi-square is used for testing hypotheses about whether your data is as expected. The basic idea behind the test is to compare the observed values, just like what I have said earlier, in your data to the expected values that you would see if the null hypothesis is true. Null hypothesis, we talk about it just like there is no association, there is no relationship, or there is no difference. With one sample, the requirements, of course, we have only one variable. And then also minimum of 2 levels of variable required. So as you can see here, I have only just one question, and then I can test right now my hypothesis, which is which brand of liquors teenagers prefer. Brand of liquor will be our variable, and the levels will be Heineken, San Miguel, Red Horse, and Tanduay Ice. We have hypothesis, and we like to know the difference to teenagers' level of liquor brand preference. So, ho and then ha for alternate hypothesis. Given the formula here, so this will be our guide to answer the chi-square or to get the chi-square. Observed frequency for O, as well as we have E, and that is expected frequency. We have here respondents, and the total respondents are 100 count. And we have also code 1 for Heineken, 2 for San Miguel, 3 for Red Horse, as well as 4 for Tanduay Ice. So that's it. And we have number of levels. We have 4 number of levels, which we're going to use later on. Observed frequency, ito yung sinasabi din nating actual data derived from the results. And to get the observed frequency, so we're going to count the number of cells. Count if, so these are actual. So brand preference, so these are the answers of the respondents. Count if B11 to B110. And then your condition, of course, if they answer 1, and that is for Heineken. How many teenagers prefer Heineken? And that is 32. If we're going to drag this down, there will be discrepancies because the cells will be moved. That's why in order not for the cells to move, so we're going to freeze it by clicking F4 in our keyboard. And after that, we can drag it down. So you're going to change only the condition. So how many respondents prefer San Miguel? 2. And that for the 3, we're going to change the condition, of course. And then how many respondents prefer Tandoy Ice? So that is 4. So total respondents is 100, and then we have also total of 100 responses. So that's right. The next one is that we're going to get expected frequency. In getting expected frequency, this is what we call predicted or anticipated data. In just one sample, this is the formula. So total of O, which is 100, over or divided by the number of levels, which is 4. 100 divided by 4, and that is 25. Just take note that this is for one sample only. Alright, that's it. And then we can drag it down, and we have total of 100. The next step is that we are going to get the difference of the observed frequency and the expected frequency. And to do that, so equals the cell of observed frequency less the cell of expected frequency. And we can just drag it down. The next thing that we will do, of course, is that we're going to get this squared. And as you can see here, so second to the raised to the second power, I should say. So what are we going to do here? So since nakuha na natin yung difference of the observed frequency and expected frequency, so what we need to do is just click the cell and then shift 6 and then 2. So 7 times 7 equals 49. 10 times 10 equals 100. And we have negative 12 times negative 12, 144. And negative 5 times negative 5 is 25. And then after that, so malapit natin makuha yung chi-square. And the last step that we were going to do is divide this to the expected frequency. So that is the formula. I want you to follow the steps, and this is for one sample. So equals I3 and then divided by the expected frequency, which is the G3, and that's it. So equals 1.96, and drag it down. So our total chi-square is 12.72. Nakuha na natin yung chi-square, but the next thing that we will do, of course, is that we're going to test the hypothesis. And to do that, there are two kinds of chi-square or test statistics that we're going to do. That is critical value and p-value. Well, critical value and p-value do the same thing in chi-square. This enables us to support or reject the null hypothesis in a test. So let's move on for the critical value so that we can test our null hypothesis. Are we going to reject it or accept it? The color green is the acceptance region. And then the color red is that is rejection region. If it is in between acceptance region, it means that we're going to accept the hypothesis. And as you can see here, there is a line in between the color green and color red. At talagyan din natin man mamaya. That will be 12.72. Of course, we need to in getting the critical value, kailangan natin makuha yung degree of freedom as well as level of significance. Degree of freedom, so it means that it is the number of levels minus 1. And our number of levels, of course, that is 4, so equals 4 minus 1. Level of significance. So this is what we call also alpha level. It is the posibilidad na makagawa ng maling decision kapag ang null hypothesis ay totoo. That's why we are using only 0.05 or what we call 5%. Kasi kapag 95%, we are confident na ang resulta ay makatotohanan. We are using 5% or 0.05 only to test the hypothesis. So since we have degree of freedom as well as the level of significance, makukuha na natin critical value. And we have here the formula. So applying the formula chi-square that CHISQ that INV.RT, open parenthesis, level of significance, comma, and then the degree of freedom. Just follow the formula and you will not be confused. So we have here 7.81. So let's go back. So our critical value is 7.81. At isusulat natin siya sa gitna ng color red and color green. We have 7.81 for our critical value. And of course, we have kanina our chi-square, which is the 12.72. If it is less than the critical value, then we are going to accept the null hypothesis. But if it is greater than the critical value, then we're going to reject the null hypothesis. So since 12.72 as the chi-square, so it means we're going to reject the null hypothesis. Ang ibig sabihin lang nun is that there is a significant difference. So that's it. You can use also the the percentage points of the chi-square distribution para makita yung critical value. So the result is there is a significant difference between teenagers' level of liquor brand preference. Just remember, in getting critical value, we need to know the level of significance and the degree of freedom. The degree of freedom is 3, as you can see here. So this is what I'm saying earlier, percentage points of the chi-square distribution. So we need to present it, of course. So in presentation, so of course, the brand as well as the observed frequency, expected frequency, we're just going to copy paste it. And then we have now the table. And then interpretation for the critical value of the chi-square. So you can copy this one. It says here that since calculated chi-square value of 12.72 is greater than 7.81, there is a strong evidence to reject the null hypothesis. Therefore, it is concluded that the preference for different brands of liquor is definitely different for the consumers. If we look at the actual frequencies in the data table, we see that the preference for brand San Miguel is the greatest, which is 35. So that's it. So we're going to move sa second type, which is the p-value, of course. So in p-value, we have here assuming that the alpha level is 0.05 or the significant level of significance. So if it is less than 5%, we're going to reject null hypothesis. And if it is greater than, so we fail to reject the null hypothesis. So in getting the p-value, we have here the formula, chi-square test, and then the range of observed frequency as well as comma expected frequency. So let's do it here. Just going to follow the formula. Then highlight it, highlight the observed frequency as well as the expected frequency, and we get 0.053. And then we're going to get the chi-square of p-value. And we have here the formula also, chi-square inv.rt. The p-value, which is 0.0053, and the degree of freedom, which is 3. So it's the same with our chi-square, that is 12.72, right? So that's it. So in presentation, just going to include the brand liquor, the value, the p-value, and the chi-square p-value. So 0.0053 is less than 5%, so we're going to reject null hypothesis. And we have right now our interpretation, which is a test was conducted for the difference in the proportion of consumers preferring different brands of liquor. And then chi-square is 12.72, should be 12.72, and then there's a statistically significant. Thank you so much.